is to always go back and relabel. Obviously with the triangles, they're going to give you your angles. All right. And when you have your angles, then you have to be able to work to the sides. Angles have capital letters, sides are lowercase. So you're just going to label the interior side lengths to know which ones are which. Little q, little n, and little p. Okay? And then you go back and you write down, what do you know? Well, I have an angle and a side, so I circle it. 65 is, I'm going to use the 65 and that 10 to find everything else. Well, in this example, little q is a what?
Opposite.
It's an opposite. Little p is a? It's a hypotenuse. And 10 is the adjacent. Which means I'm going to use adjacents and an angle. Adjacents and an angle to find the opposite and the hypotenuse. I just reuse those with two different trig functions. That's what we're doing. If this 10 was the opposite, then I would use sine and tangent. Same deal. You're reusing given information to solve each part independently. So I have to find little q, little p, and angle n. So how do I find an opposite knowing an adjacent?
Tangent.
The tangent of 65 then is that little q over 10. How do you get it by itself?
Small
Press some buttons in the calculator, always round to two decimal places, and you get your opposite side. Excuse me. You do the same basic idea then to find p. P in this problem is a what? How are you going to find the hypotenuse reusing the adjacent? Cosine. Let's use cosine then.
Now you have to change this.
Yep, and now we just switch them. That's what you're trying to accomplish. You're reusing given statements to get to the next part. Okay? By doing that, you're going to be less likely to screw something up. Yes, sir?
Is it okay on the homework I did data instead of like not the letter?
Yeah.
Sometimes, and then just put data equals.
That's fine. That's fine. It's not a big deal. Because then you would have, I mean, this one's a subtraction. The complement of 65 is what? 25?
25.
Then those two you just round out. Okay. This hasn't changed from what you did last week at all.
It's like, it's easy, but deep down it's hard, but it's easy.
It's the exact same thing we've been doing for the past 2 years.
Yeah. I felt that way the whole time. It doesn't feel right.
Say compared to last
Same idea. This one, this is your example that you have two sides. Excuse me. This example that you wind up with having to solve, you have two sides. You need to find your third side. Then you need to find the two angles. Same deal. Label your parts that you're going to be looking for. Well, I have little d, little f, little e. Which means I need to find that little side d. I have to find angle f and angle d. Go ahead and use the Pythagorean theorem right away to find that side length. Is that side length a leg or a hypotenuse? It's a leg. So, $81 subtract 9, and you get 6√2 when you simplify that out. Obviously, the calculator, when you take the square root of 72, will spit out 6√2 for you. If the problem says simplified radical form, or if it says decimal. If it says decimal, then you would round it out. I believe that's a little
Like
over,
8.5.
okay. 2 decimal places, 849 then? Okay.
Wait, is there like for the lettering, like how you put D? I accidentally put like
It's fine, but that's, what I'm saying is that's the side that you're looking for. Okay, that's what you're looking for. So now you go back, you've got that side length, now you go through and you find your angles. Well, you start at angle F. That makes the 3 a what? 9 is a, what are you gonna use? Fine. And then how do you want to do it?
No, inverse.
No, it's the inverse. Finding the angle, you're using the inverse. Anything on the calculator. Okay. Exact same thing, switching to D. But you change your perspective. Going back to the given values of 3 and 9, if I'm at D, 3 is now my what? It's my adjacent. Now it's my adjacent.
So I just, if you would do cosine.
I use cosine.
okay, it's just like if you already know that equal, you can just like subtract it.
What if you're wrong?
Once you know you're wrong.
How do you know it? What if you accidentally used cosine here? What if you used cosine there for angle F? And you got the wrong answer. Would you get this answer right? No. Never use what you have unless it's an absolute necessity. We'll have a situation of that sometime next week, but it's a very rare occurrence. Reusing givens allows you to make a mistake at one point and not remake that same mistake.
Wait, do you know what I was saying?
Yes.
What?
If you got this angle measured, you get the confidence to get this angle.
Yeah,
What if this was wrong?
yeah, okay.
That's what I'm getting at. So then you do the same deal. And I don't know why you guys are all freaking out when it comes down to this whole having to do more than one part. This has not changed in the setup of anything over the past 2 weeks. We're still setting it up exactly the same way, okay? Everything gets set the same way. Now, when you round all that stuff out, what'd you get for the inverse sine of a third? 1947, thank you. And then this one you should have gotten what?
70.5.
70 point. Good. And then now, one thing that you can always check, now that you've done all this, these two should add to 90. And they should be within, a 100th or so, depending upon how you round it, if you round it correctly. Okay. Now, remember, excuse me. Wow. What happens a lot is that you guys will just sit there and say, oh, I just use what I want. And you don't write anything down, and you just try to press buttons. The whole reason that I'm trying to get you guys to write this stuff out is so that it makes everything easier in the long run. The more you see the stuff written out, the easier it becomes. Two sides, find angles. When I did this one, was my missing side length a hypotenuse or a leg? It's a leg. So that's going to be a little g.
I have a question.
Yes, sir.
Why isn't the Pythagorean theorem a rule?
Why is it a rule?
No, why isn't it? Like, why is it just a theorem? Like, because isn't a theorem something like, it's just like almost like a theory?
Well, all right. The theorem is It's, you're trying to think of it like, why isn't it law?
Yeah,
Okay.
that's what I was asking.
I don't know. Maybe it's in the stages. I don't know.
I just wasn't sure if there was like one that could like prove it wrong.
No, because the Pythagorean theorem is used for a two-dimensional plane, and maybe I don't know. Yeah, you can Google that if you'd like. What?
Oh, I didn't realize it right now.
So this one here, you're going to have 14 squared plus something squared is 16 squared. So what is that, 256 minus 196? So that'd be 60. What is it, 4 times 15, 2 root 15? Is that correct?
Yes.
Going through further, does it say anything?
Yeah, it sounds like you were using theory and law for things like rules as physicists sometimes do. Traditionally, mathematicians will call any significant result worth remembering a theorem. The Pythagorean theorem is an archetypal example. We use law sometimes too, but it's really the exception to the rule. Like law of quadratic reciprocity, there really isn't a standardized use of law in mathematics. In mathematics, a theory is a large coherent group of results in the same field of study.
Okay. Well, I guess, there you go. I never thought of, I honestly didn't know that.
Yeah.
So math people are leaving the door open that there could be something that could get screwed up.
Yeah.
We're pessimists. I forgot what's called for a second there. Yes, ma'am. So now we find angles G and angle J. Relationships on the sides then. 16 has to be the,
Hypotenuse.
and then 14 is your Jason. I'm at G. Okay. So I'm going to use cosine. That'll give me my angle G. Same thing then for J. Now if I'm at J, 14 becomes an opposite because you're looking at it. Remember when you're at G though, this it's an adjacent, but then when you get over here, oops, when I get over here, it becomes an opposite. So your perspective switches. All right. Little tip. What's that? A lot of times, just so you remember, when you're finding your two angles, you're going to use two different trig things. Same thing here. When you're finding your two sides, you're going to use two different trig values to find them. Okay, because you're bouncing around. Yes, sir. It just might be dumb luck. You know, seriously, it just depends on the problem. So then this one would have been sine. And you go from there. Okay. I'm sorry, excuse me. It's awful.
Boom, boom, boom.
One last one with another angle one, just to make sure you're setting them up okay. You know, I'm done. I don't care anymore. You have an angle and a side. Oh, done. You guys are just use your time wisely in the hallways from now on. You have an angle and a side. You have to find two sides. So you start with what you know. You got your 57 The 15 is in what? Which means this is a adjacent. And now you're gonna have a hypotenuse. Just like we've said before, when you have to find two different side lengths, you're probably gonna want every time, whether you're finding two angles or you're finding two sides, you're gonna have to use two different trig things because your perspective is gonna switch. What am I gonna use with opposite and a hypotenuse?
Fine.
How do you get the hypotenuse by itself? Do you have an angle?
No. Yes.
Do I use inverse?
No.
Okay. And that gives you your hypotenuse. To get to the adjacent, using your opposite, what are you going to use? You guys should know these things well. We've been doing this for a long time now. And again, you have an exchange of change in this case. Excuse me. And you solve it out. The easiest thing to do then, yes sir?
Is it okay, like when you put adjacent, I put like T?
Yeah, absolutely. You know the reason why I didn't do it on this one?
Why didn't
Look at all the 5s you have and the S's. That's why I didn't write this as a little S, a little T, and a little R. And that's perfectly fine. Because I did this first hour where I wrote this one out as the sine of 57 is 15 over S. Boy, it looks like a whole load of 5s and S's. So that's why I didn't write. I wrote it out with the word. Either way is perfectly fine. That's the only reason why I didn't do that. First hour, everybody freaked out when I wrote it out with the S. Like, oh my God, what is that letter? Oh boy. So here I thought I would change it. You freak out that I didn't write it with an S. You can't win. Lastly, the reason why I try to hold off on these angle ones is because more often than not, what you're going to screw up,
Use that.
well, you use the value, but what you'll screw up is you'll think you have to go to 100, and not 90. So the complement of 57 is what?
I thought it was 23.
33.
34.
33 degrees.
Okay.
Fahrenheit, no.
Excuse me. So that's what most of you guys tend to mess up. Remember, complements are going to 90. The other thing I wanted to look at with you guys today was, again, a reoccurrence of drawing pictures. Some of the things that I wanted to make sure that we understand. Now our youngest got it too. So it's not What's that? I'm telling you, our youngest got it really bad last night, and it's just this nightmarish thing.
No, I wasn't caught up because you just I had a pulmonary embolism, so I said it was.
Oh, that's usually not good.
Yeah. What about your other class?
A wooden beam, this is the third one. Let's draw it out. A wooden beam is 24 feet long, leans against the wall, makes an angle of 71 degrees with the ground. How high up the wall does it reach? A wooden beam, 24 feet long, leans against the wall and makes an angle of 71 degrees. So, if you're leaning something against the wall and you know that length, what part of a triangle is that then? Good. Sometimes you will be given the length of a hypotenuse because when you lean something against the wall, you happen to know how long that part was, you're leaning it. When you lean something against the wall, what else does it touch?
The wall.
And the
Ground. So that would be the angle.
The angle up at the ground would be which one? The one on the ground or the one up the top of the wall?
On the ground.
What are you trying to find? Opposite, very good. The height up the wall. Okay? So, a lot of these things with their elevation and depression, you can kind of take for granted the fact that they are right triangles. Okay? Generally speaking, walls are straight up and down and they make right angles to the ground. Otherwise, it's the Leaning Tower of Pisa.
Like a Despicable Me.
Yes.
And it doesn't have any right angles either because it's a circle.
So here, what's that? It's actually the town of Pisa, yeah. Or one in Niles. There's a replica of it in Niles. What trig function are you use?
Sine.
Get the opposite side by itself, you just multiply out. And what'd you get? What was it?
22.6.
Anything with it?
Ooh.
You'd be surprised the amount of times that people still have issues with drawing pictures. Okay? It's not meant to be a gotcha of any sort to getting through this thing. Okay?
Do you make
These? No. No.
I was gonna say, you're a great guy.
Are,
It's called the internet.
you said every single one of these are right angles?
Yeah. We will deal with next week non-right triangles and finding and measuring distances and stuff. But we'll do that next week. What happens is the way that we pace ourselves through for the different units, we have the whole full unit on right triangle trig, which is basically what we're doing right now. Next week, what we do is we look at, since it always kind of works itself out where it's a shorter week, we work through what are called the law of sines and the law of cosines, which are how do you solve for side lengths and angles if you don't have a right triangle. And they're formula based, it's a lot of plug and chug, but it's a matter of you have to use it a couple of times. So a plane takes off from field, rises at an angle of 8 degrees with the horizontal ground. As the plane flies over the water tower, it covered a distance from the point of takeoff of 2,000 feet. How far apart are the takeoff point and the water tower? So, what do you have to draw?
A plane.
A plane, a water tower, and a
Horizontal.
field, ground.
A hamburger stand.
There's your water tower.
Yeah, water.
It looks like the decal bar. Don't confuse drawing, it's not on a scale. You're welcome, it's the work, yeah, I got
So it looks like a jigsaw puzzle, sorry. That was,
you. It looks like a table
This
tennis. Doesn't you ever just say table tennis?
She just has to come and play.
You say UAV.
Okay, you got the picture, okay.
Oh, I see you.
Oh, that
I
deserves
coughed in my hand, so there you go.
it. Yeah,
Wait, did you just draw that?
yeah.
Bad skills.
Why y'all
He
think
colored
he
it in
can't
there.
draw?
So the plane takes off. The plane takes off, and it clears the water tower. That's not. This is what the Wright brothers plane looked like. You guys have never seen the Wright brothers airplane?
Yes, I've read the book.
Okay.
So he's lying down here.
Sorry.
It's probably not the safest airplane ever, but whatever. Anyway, so that angle of elevation rising up was how many degrees?
8 degrees.
8. 2,000 degrees.
Is that the water?
So that's the that's the angle of elevation that's taken off at 8 degrees.
Yeah.
Now, it says that when you're measuring the distance of an airplane, the airplane's traveling up, and away. So that's how far it's traveling. So the hypotenuse then is 2,000.
Oh,
And
wait.
now we're trying to find.
Because
shucks.
because it's asking you to figure out how far is it from here to here. When it's asking you to find how far it was from the takeoff spot to the water tower, that's what you're looking for. So, is this distance here an adjacent, or is it a an opposite?
It's an adjacent.
It's an adjacent. So, what trig function are you going to use, knowing an angle? Please move.
I way too fast.
Okay. And then I'll give you that. Now, for fun, how tall is the water tower? What would you do to find the water tower then? How tall the height of the water tower?
Would you do hypotenuse and opposite?
Right, so which one are you going to use? Sine. So if I wanted to figure out how tall the water tower was, the height of that, I'd say the sine of 8 is our opposite. So how far was that horizontal run?
1,980.45.
1,907.
1,980.
Oh, that's right, 1,900, so 1980.54. So somewhere in the year 1980 in June.
Yeah.
And then the, what was the 2000 sine of 8 then?
Wouldn't it be May?
Half a year?
Oh, yeah. Okay. You're.
Ah!
I appreciate you, but I didn't think it was that funny, but.
No, it was only that funny because it took me like a year to get it. Like,
Was it
Yeah,
till,
I
was
still
it till
don't
May
think it
or June?
yeah, June.
Would
no,
you-
it has to be 0.6. You have to-
Oh my gosh. 0.5 equals
But there's
half.
12 months though.
Oh my goodness.
I'm so dead. I'm sorry. I'm like lost.
What's half of 12?
6.
Okay, what's half of 10?
5.
How many months are in a year?
12.
So what's halfway through the year?
6.
So if I'm
That's what I
saying,
just said.
no, you said wouldn't have to be May because you said 5.
Yeah, cause like I thought I literally just said 6. For June.
What if you did
No.
that?
Right, which is halfway through 1980.
Well, yeah. Oh, okay, now I get it. Go.
What does this have to do with months?
If that wasn't a great, leave me alone, jerks. Deflecting it from you, leave it alone. How tall was the water tower, just so we can save ourselves now? 270 feet?
278.
I don't know, does that sound about right?
1.5.
I don't know, I think.
200, about 278 feet? I don't know how tall the water tower is. That's like a 20-story building. Okay, get out there, get a tape measure. So. Seems like that's a very tall water tower.
Let's go measure ours right now.
I'm busy. I'm coughing. I don't feel all that great.
Wait, wouldn't you be able to measure it though, like how we did the straw and the thingy?
You want one?
Could you measure it? I'm not gonna use it.
Yeah, you could.
I hate when someone just stuck in my head, because I don't even want to stick on that every time.
Yeah, I watched the
Flip over to 8. Find the measure of the angle of elevation of the sun when you have a vertical post that is 15 feet tall that casts a shadow 20 feet long. Excuse me. So you have your sun.
His name's Ralph.
Beautiful.
Looks like the Nickelodeon splash.
Ah, it does.
I forgot to put the smiley face in there.
Oh, what a beautiful sun. Oh, I thought you meant like a sun, like a person's sun.
Me too.
Wait, tell
I was like, that's a crazy hair.
I was,
Not like a real like sun.
Because you said you have your son.
yeah.
You have the sun.
It says S-U.
It's an onomatopoeia.
But I wasn't reading it. I was just listening to him, and then he started like drawing like hair. I was like, what the heck?
You said like your son, not the sun.
I said the sun.
No, you
No,
said
you
your
said you have
son.
your son.
You got your son. So
Yes.
And I was like, oh, you have like you're drawing with
That still
person.
makes sense.
Anyway, so it's got the sun's rays.
So bright.
What if you gave birth to a star?
What?
That hurt.
Which one is this? Oh, I don't know what to do this.
The post, when you have a vertical post, which direction is vertical? Up and down. So your vertical post is 15 feet. Shadows. Last time I checked, shadows are cast along the
Ground.
the floor, yes. So our shadow,
Guys, look like shadow on my head.
No, I swear we had a problem the other day. It said the shadow and it was on the high top. I remember.
and you did it wrong.
That's the shadow, like the sun would be like up here.
Yeah, yeah, but that's different. Dude, I swear I got it right.
Yeah, dude.
Anyway, is this the angle here, elevation, or is the angle up top the elevation?
The up top.
Elevation, is it up top or is it on the bottom?
Bottom.
Bottom. Angle of elevation is line of sight, looking up.
Oh, I have a question.
No, yeah.
Line of sight looking up is your angle of elevation. So if I'm at that angle, I have two side lengths. I have a 15 and a 20. What are they in relationship? You're right, I'll use tangent, but what's 15 according to this? Opposite. I don't have theta, I have to solve for theta, which means I have to use my inverse. So theta is the inverse tangent of 15 over 20. Ah,
What did you do?
I screwed
How about
something up.
gotcha?
Forgot to make a 0 with that. Okay. On Friday, you're going to have to be able to draw pictures and do stuff like that. Also, I want to quickly review with you. Yes, sir.
Is all kind of like outside.
What's that? No, logarithms are completely different. Logarithms are for when you have something like this. What's 2 squared? What's 2 to the 3rd power? That means 2 times 2 times 2. 8. Two to what power is 6? And that's how you log. This would be.
So what is the lowercase guy?
That's what you have to do. What, this number? It's a exponential function.
Boy, that's not even our class.
So real quick reminder. You have special right triangles. Special right triangles, you had to worry about ratios, which meant that, I don't know, were there spares? What did you guys have? Right there. Oh, thank you. I got lazy, just kind of choke out. So take a look at number 5 real quick. Number 5 here. Number 5 is a special right triangle. Is it in 30-60 or is it in 45?
30-60.
It's in 30-60. The reason why we know it's 30-60 is because there's a 60 in it. Which means we have to remember the ratios of our sides. X, x root 3, and 2x. There's a common ratio that happens within all of these. You have to figure out what that common value x is throughout the whole triangle. That's how you're able to replace your values. So in number 5, you happen to know across from which angle? The 90. The 90 you know is equal to 4, which meant you had to set up and solve a one-step algebra problem. In this case here, how do I get x by itself? I divide it by 2, which means my value of x is 2. Therefore, I take that value of x and I put it everywhere I see an x. And that's how I get my other side lengths. When you're working with special right triangles, this is the scenario that happens time and time and time again. It's a matter of getting the value that's the common multiplier. Same deal if you look at number 7. Number 7 gives you, is a 45, 45, 90, and they give you the value across again from the 90. But the ratio of the sides were different. So there I would set the x times the square root of 2 equal to 6. Which means something had to be multiplied by the root 2 to equal 6. To figure out what that something is, you have to divide by the root 2. Now, you guys have the calculators that will simplify this out for you, and you're going to get 3 root 2 for that common value. All right, it gives you 3 root 2 for the common value when you divide it out. Which means then, everywhere else I see an x within that triangle, what do I replace it with? 3 root 2. It's 3 root 2. 6 divided by the square root of 2, when you rationalize that out, you get 6 root 2 over 2, which is 3 root 2. The calculator does the work for you. You have to know how to use your calculator. That's the issue. Okay? Now, I wanted to get these 2 sets of papers into your guys' hands a little bit early. That way we had enough time today to go through it. Also, to have the time tomorrow to get any extra questions. These 2 worksheets I will collect on Friday. So you've got a bunch of review problems in front of you to work yourselves through. The one thing on here that you'll see, on the one I just gave you guys, the first grouping was just finding missing side lengths. Do you see anywhere in there where they give you that it's a 30, 60, 90, or 45, 45, 90? No. So you just use Pythagorean theorem. When it says find missing side lengths, leaving them in simplified radical form, you have special right triangles, that's when you're going to use your specials. As you flip that over, the next 8 are solve the entire triangle. Whether you're given 2 sides, find the third side, find 2 angles, or you're given 1 side, 1 angle, find the other 2 sides, find the other 2 angles, which we've done now for the past couple of days. And then last one's another couple of extra problems and working your way through there. Yes, ma'am, Tori.
You said that both of them were Friday?
Yeah. Okay. sure you guys are on the right track on this. Now remember, make sure that you guys are writing out what you're doing before you do it. It forces you to know how you're setting the stuff up. If there's any one thing that I can tell you guys to do that's extremely helpful, that's it. Okay? Oh, I'm sorry. Excuse me. Ugh. I really don't wish this cough on anybody.
Not even your worst.
I had it last week.
Ugh.